everyone, welcome to Zeal Maths JEE and Beyond, where we cover those topics which are usually not covered in your JEE preparatory classes. Special subtopics and special topics. One of very interesting topics in your JEE preparation in maths course is permutation and combination. In a wider sense, this topic is known as combinatorics. So I'm going to pick one subtopic of this PNC thing which is usually not covered, and that subtopic is bijection. It is also known as two-way counting. It is also known as combinatorial argument. I have already covered bijection and you have also covered bijection. Any JEE preparation is not required to cover bijection because it was the very first chapter of your 11th CBSE, set relations and functions, where you got to know about bijection. So everybody knows what is a bijection. It is a one-to-one correspondence between two sets. Everybody knows what is a function. How this bijection thing is associated with combinatorics, that I'm going to show you here. Let's start with our first problem, which is based on bijection. Look at this. The picture seems very interesting because Jack is at 0, 0 and Rose is at 8, 7. There is a network of roads between them. Some roads are going from west to east, some roads are going from south to north. And you know what could be the question? Jack wants to meet Rose, but he has to take a shortest path. What is the shortest path? Of course, he can move to right, goes up, goes left, down. I mean, there could be so many paths if I am not using the word shortest. There could be infinite ways to reach at 8, 7 where Rose is. Right? But when I say shortest path, that means, obviously it is very intuitive to think that Jack has to take 8 right steps and then Jack has to take 7 up steps. That is just one path. How many such paths are possible? Still confused? I'll show you a video where Jack is trying to reach. You can see Jack is trying to reach towards Rose in this video. What did he went for first? He went for 2 rights, then 3 ups, 4 rights, 3 ups, 1 right, 1 up, another right, and Jack meets Rose. I think this video makes it clear what is the shortest path because we are only taking right steps or up steps. Alright? So let's get back to the question. I will read the question now. In how many ways Jack at 0, 0 can meet Rose at 8, 7 by taking a shortest path in this grid? And he has to choose the shortest path. Alright, so now you can pause your video, you can try to solve this problem, and the time starts now. Pause it. Congratulations to those who solved this problem, and nothing to worry if you were not able to solve this problem because a similar problem, in fact a same problem, was asked in IIT JEE Advanced. Do you believe it? So problem is obviously tough. How should we go for such a problem? What should we think? And how this problem is related with bijection? So the first thing which makes this problem difficult is the number of roads here, the size of the grid here. Right? Do you agree? What can we do? We can form a similar problem which will be comparatively easier because we can reduce the size of the grid. So let's go for this grid here. Right? It's a small grid. Jack is here, Rose is here. Suppose Jack is talking to his dad. Jack is saying, Dad, I'm going to Rose's place. Dad, counters, why are you going to Rose's place? Okay, that's not the question. Dad asked him, what is the path you are taking? Now, how will Jack reply? Jack will say, Dad, I took a right. Then I took another right, and then I took an up step. That was the path. Maybe another day, Jack was again trying to reach Rose's place. Again, his dad calls up and he replies, this time I took one right, one up, and one right. End of the day, and the path could be an up step, a right, and a right. It was easy to count because the size of the grid was smaller. And I can tell you, I can conclude here that there is no other shortest path possible. How I am so sure about it? How can I say that? Think. And if you want to pause the video, you can pause it and think. How in this question I said, without looking at the grid again, that there is no other path possible. Nice if you got it, because it's very easy to comprehend that here we have 2 R's and 1 U. Forget the question. In every row, I have written 2 R's and 1 U. 1 U and 2 R. Suppose the question is, in how many ways I can arrange 2 R's and 1 U. Now I surely know there is no other way possible because U was at 3rd position, U was at 2nd position, and here U is at 1st position. There is no other arrangement. How arrangement of U R R is related to this problem? Didn't I say this is a path? Jack told his father. Yes. If you look at this set which contains these 3 arrangements, it can be easily connected to another set where I can write this is the first path, this is the second path, and this is the third path. Now you're getting the idea, don't you? This is set A, this is set B. I wanted to count the number of elements in this set, the cardinality of this set. And what I did, I framed a different question. In how many ways I can arrange 2 R's and 1 U? Answer came out to be this. Answer is 3. But since there is 1-to-1 correspondence, look, there is 1-to-1 correspondence. What is a 1-to-1 correspondence? Every element of this set, every one element of this set is related to one element of this set. Right? This is bijection for you, isn't it? So how do you solve a combinatorics problem, a PNC problem using bijection? It's not that simple. I will not say the word simple here, alright? Because it is not simple. You're using bijection because the problem itself is very tough. The first thing you have to do, you have to form another set, another question. The question which you can solve easily, where you can count the cardinality of the set easily. Like here, I have counted 3 arrangements very easily. The next thing would be, I will try to give an argument which will prove this 1-to-1 correspondence thing. The moment you do that, because bijection is proved between these 2 sets, the number of elements in this set should be equal to the number of elements in this set. So answer here is going to be 3 only, right? 3 paths. Then again, there are few of you would be thinking, what have you done? You just wrote 3 steps, right? And you are just telling another way to explain these paths. If I could have done this finger counting, then I could have solved this problem as well. How did you get this answer 3? Because PNC is not about this type of counting. It is counting without counting. So I think everybody has covered the very basic idea of arrangement where we have to arrange 3 objects in a row, out of which 2 are identical. What is the formula? Oh, I know. Formula to sabko yaad hota hai na? So what is the formula? It is 3 factorial, because 3 objects, 3 factorial, and why it is divided by 2 factorial? Because there are 2 identical objects. This formula gives us answer 3. Alright, so I have solved a very different problem because the grid was very small. But the sense of the problem, the idea of the problem was same. Let's apply this idea to this question. We will go to our next image. Our next picture is there. This could be another path, right? This could be another path. This is path 2 for you. Those who are still struggling somewhere, what is the shortest path, what is not, this is another example for you. If we go to next picture, the next picture here will show you the first path, which I have shown you in the video, 2 hours, 3U, 4 hours, and in the second path, I've just shown in the recent picture. So these 2 paths are what? An arrangement of 8 R's and 7 ups, isn't it? In how many ways we can do that? We have a formula, right? If we have a formula, nothing is going to stop us. In how many ways we can arrange? Question changes. In how many ways we can arrange 8 R's, 8 R's and 7 U's? And your formula tells you what? It is 15 factorial divided by 8 factorial into 7 factorial. Right? Which can also be represented as 15C7. So what is 15C7? 15C7 is the number of ways in which 8 R's and 7 U's can be arranged in a row. But that arrangement itself is nothing but a path. So this is the number of shortest paths possible. We got our answer. If you want to verify, in the next picture here, you will see the answer. 15 factorial divided by 8 factorial into 7 factorial. 15C7. In the same picture, you can see there's a question. Can you give a combinatorial argument for 15C7? Yes. So I will tell you about combinatorial argument, but I need some space here. So I will shift this picture to left. All right. Look, the picture is coming to the left. I'm coming to the right. Yes. So let's talk about combinatorial argument. What is a combinatorial argument? 15C7 is the answer. But before that, we got 15 factorial divided by 8 factorial into 7 factorial, which converted to 15C7. I want you to provide an argument, a method which can give me this answer directly. 15C7. And everybody knows what is 15C7, right? 15C7 means 15 choose 7. You are selecting 7 objects out of 15 objects. So how selection of 7 objects out of 15 objects is answer to this grid problem? If you want to think, you can pause the video right now and think over it. You can pause it now. Very nice if you got your solution. Maybe it is entirely different from what I am going to tell you. But if it is logically correct, I'm okay with that. You should be okay with it. So how 15C7 is your answer? It's very simple. Every path we wrote over the board or in the slides was consisted of what? 8 rights and 7 up. That means there was a string of 15 letters. Now if I let's say make 15 blocks here, all right, 15 blocks. I'm not going to make all 15 blocks here. Suppose these are 15 blocks. Alright? This is the first one, second one, third one, fourth one, and so on to 15. What we are going to fill in these blocks? Yes, you're right. There will be 8 R's and 7 U's. 8 R's and 7 U's. Where in these 15 blocks? How will you fill that? 15 C8 or 15 C7. Sounds nice? So that's what a combinatorial argument is. Another way to approach the same problem. Okay? So I think you have got a nice idea about this problem which was asked in IIT JEE. But as I told you earlier in the beginning of the video, that our intention is to go beyond JEE. So let's see some variations of these problems. Problems which may seem a bit tougher than this problem. But somewhere the idea is based on, the fundamentals will be based on this problem only. So now let's take a look at this variation. In the next problem here, this one, there is a variation. And the question is, how many shortest paths are there from P to Q? Now you can see there are 2 grids which are connected at a point R. Now you have to count the number of rights, the number of ups or downs, and you have to give me an answer. You can pause the video now. You can solve the problem. After that, I will tell you the solution, tell you the exact answer. In between, I will clean my board as well. Go ahead, pause the video.